Far beyond Earth, in the icy shadows of the outer solar system, a mysterious moon is rewriting everything we thought we knew. This is Enceladus, a tiny moon orbiting Saturn, shining like ice and hiding an explosive secret beneath its frozen surface. It may look lifeless, but Enceladus is alive, with towering cryovolcanoes rupturing its crust, venting water vapor and ice into space. Unlike Earth's volcanoes of fire, these cryovolcanoes erupt with ice, water, and volatile compounds, sculpting the moon with frozen fury. Scientists once thought such tiny moons were long dead, geologically silent. But Enceladus refuses to be silent. Its south pole is fractured by deep canyons called tiger stripes, shimmering blue, where the surface vents warm material into space. These geological scars are the source of Enceladus's mysterious behavior, erupting with astonishing power again and again. But how did scientists discover that this moon was active, so far from the warmth of our sun? It began with Cassini, a spacecraft sent to study Saturn, which in 2005 flew directly through Enceladus's icy vapor. Against all expectations, Cassini detected water vapor, organic molecules, and complex chemicals, signs of something extraordinary beneath the ice. Scientists were stunned. A moon once thought dormant was now spewing ingredients for life into the vastness of space. They called it a cryovolcano, a volcano not of fire, but ice, powered by hidden heat and shifting tides. The plumes rise hundreds of kilometers above the surface, shimmering like ghosts in the sunlight before falling back like snow. Much of that frozen spray returns to the surface, but some of it drifts off to form Saturn's E-ring. Yes, Enceladus is literally contributing to one of Saturn's rings, feeding it from its own icy heart. But the real mystery lies beneath the surface, where an entire liquid ocean may be churning in darkness, an ocean world sealed beneath kilometers of ice, warmed from within by tidal forces stretching its core. Just as the moon pulls at Earth's oceans, Saturn tugs on Enceladus, stirring its insides with every orbit. That tidal force generates heat, not from sunlight, but from constant flexing of the rocky core beneath the ocean. This heating may drive hydrothermal vents on the ocean floor, like those on Earth, where life thrives without sunlight. Could similar ecosystems exist below Enceladus? Could this freezing moon hide life in its blue-black ocean caves? We don't have direct evidence, yet. But the chemistry in the plumes is tantalizing, hinting at biological potential. Cassini even detected silica particles, likely formed by hot water interacting with rock on the seafloor. Such conditions mirror those that once gave rise to life in Earth's oceans, deep, dark, and full of energy. Enceladus defies our past assumptions because it's geologically active, even though it's tiny, cold, and billions of years old. Most small moons cooled and froze solid long ago. Enceladus simply shouldn't have any heat left, but it does. The heat escapes through those cracks, melting pockets of ice, building pressure, and propelling jets of frozen sea. The result is a world that continues to change, windswept with ice deposits and surface patterns mapped by geysers. Each new eruption weaves a fingerprint around the South Pole, shaping the terrain like sculpture in slow motion. Over time, material pushed up from deep within could even resurface entire regions of the moon. That means Enceladus is actively reshaping, not a static ball of ice, but a dynamic world in motion. Across the solar system, Earth is no longer the only world with volcanic activity shaping its destiny. Cryovolcanoes aren't just rare oddities. They're windows into hidden oceans, pressurized chambers, and the strange mechanics of alien geology. And Enceladus isn't alone. Other icy moons, like Europa and Triton, may have cryovolcanic activity too. But Enceladus is different. its plumes are active today, proven, and bursting into space before our very eyes. We've seen it, not in theory, but in high-definition photos, captured in nanoseconds from a robotic explorer. Cassini dove through those geysers, not once, but multiple times, sampling the chemistry of a hidden sea. It revealed salts, methane, carbon dioxide, and surprising amounts of hydrogen, the potential signature of hydrothermal activity below. And hydrogen indicates energy, the same kind used by primitive life on Earth in the darkest oceans. It's not proof of life, but it's one of the best places we know to look for it. Now, scientists dream of a new mission, one that could land on the surface or dive into the plumes. Imagine flying a clean robotic sampler through a fresh jet, analyzing particles for complex organics or even biosignatures. Such a mission could answer one of our oldest questions. Are we alone in the universe? For now, we watch from afar, studying each shimmering plume as a whisper from a hidden ocean world. And the moon keeps whispering, steadily, strangely, against all cosmic odds, telling us there's more beneath the surface. This frigid moon, once overlooked, now holds front-row status in the search for alien oceans and maybe even alien life. Geology, chemistry, and mystery converge on this icy orb, where science meets something deeply human. Hope, because even in the coldest corners of space, we find warmth, not in degrees, but in the pursuit of truth. This moon, with its giant ice volcanoes, won't stop erupting, won't stop reminding us we've only just begun to explore. And maybe, just maybe, those plumes are the first signs of another chapter in cosmic biology, a spark beyond Earth.